Anyone fascinated by the natural world has probably wondered why some animals have such strange-looking sense organs. The elephant with its huge ears, the antennae of a butterfly, which up close look like feathers, the snake with its split tongue. And what about less obvious enhancements, like the sensory cells on a crocodile's skin? Surely these evolutionary traits aren't just for decoration. In fact, the size, shape, and location of these animal sense organs is all for a purpose. And just like us, animals rely on their senses to communicate with each other, find their way around, stay safe, and most importantly, to find food. When you see how superior some animal senses are compared to those of humans, you might wonder how we ever managed to stay on top of the food chain. Animal super senses. You won't believe what's possible. Welcome to Animal Super Senses, the show that enables you to see it, hear it, taste it, smell it, and feel it like animals do. Animals use sight, smell, taste, touch, hearing, and other special senses to negotiate their way through a sometimes cruel and unforgiving world. On this episode, we travel from the desert to the forest, Australia to Borneo and back to learn how species as diverse as bat-eared foxes, the bilby, deer, kangaroo rats, cicadas, proboscis monkeys, and other creatures never miss an auditory trick. In these huge expanses of shrubland, grazed and fought over by some of the most recognizable wildlife on the planet, we find this particularly curious critter. The bat-eared fox makes its home in areas with short grass and low scrub, feeding on mostly insects and invertebrates. To get a hold of creatures that small, it helps to be able to hear them. So the large ears of the bat-eared fox aren't just for decoration. They're filled with blood vessels which help cool the animal down during the day. Just as well, because it gets hot out here on the savanna. But their ears are also an effective sound gatherer, funneling sound to the inner ear. What's more, these swiveling ears can turn 180 degrees to help locate their tiny prey, as well as the animals that prey on them. Bat-eared foxes have to be especially alert to the sounds of the slender mongoose, brown hyena, and black-backed jackals, all of which can kill and eat bat-eared foxes at regular intervals. Good hearing in general is a huge advantage for animals who would rather avoid being eaten. The desert offers lean pickings for omnivores, with sparse vegetation, meaning fewer places to hide. The bilby seems to spend most of its time avoiding being eaten. A marsupial, in fact the largest known member of the bandicoot family, the bilby is truly a nocturnal animal. They usually don't come out of the ground until long after dusk and head back an hour or two before sunrise. If it's a full moon, or there's heavy wind or rain, bilbies will stay cooped up in their burrows all night. When they do get out amongst it, they rely on their hearing to survive. Notice their large, mostly hairless ears, which allows sound to pass unheeded to the inner ear, and also helps to amplify sound. In fact, it's not unlike the effect of cupping your hands behind your ears. But of course, there's a lot more to animal supersense of hearing than having outsized ears. Take banner-tailed rats, for example. Their hearing is so keen that they can hear wind ruffling the feathers of an owl flying through the forest at night. Yet unlike the bat-eared foxes we saw earlier, the ears of the banner-tailed rat aren't particularly large in proportion to the rest of their body. It's the large feet and hind legs that stand out on this animal. No, with the banner-tailed rat, all the precise audio engineering work goes on inside the creature's ears. Banner-tailed rats have a huge eardrum beating away inside that medium-sized ear, and a larger than usual middle ear chamber to boot. Large bony structures surrounding the banner-tailed rat's inner ear enhance their extremely sensitive hearing. Size is no guarantee when it comes to animal sensory strength. Some of the smallest animals have the largest powers of hearing and auditory communication. Though their habitat is different, deer are another animal who rely on their sense of hearing to stay out of the way of trouble. You'll note that they too have large pinnae ears which move independently. This directional hearing means they can zone in on where a sound is coming, and it is believed from how far away, meaning how fast they had better run to get away from it. This, in large measure, is why it is so hard to sneak up on a deer in the woods. And as all those deer hunters out there could possibly attest, deers instinctively distinguish between the sounds it hears every day in the forest and unfamiliar noises, such as the opening of a car door or human footsteps. In some respects, hearing is the most important of deer senses. For though their sense of smell is acute, an ill wind can always blow outdoors in an unhelpful direction, whereas they can rely better on their ears to guide them. Deers also hear things at a higher frequency than humans, though we can pick up on things lower in the spectrum than they can. Rodents, such as the lowly rat and humble mouse, come with the gift of ultrasonic hearing as standard equipment. That means they can hear in a frequency above the human ear's audibility limit. The hearing range most often means the range of sound waves and vibrations which can be heard by humans and other animals. The easiest way might be to imagine a piano keyboard. Humans typically hear notes in the middle of the keyboard. Others very high or very low are inaudible to us. At the lower end of the scale, rats and mice and other rodents don't just make the squeaky noises we humans are able to pick up on. Oh no, they are able to communicate in a whole rich world of sound and auditory cues, but outside of our range of hearing. Imagine what it might be like if we could hear it. Larger animals that are able to hear things in the infrasonic range tend to have large heads, as in larger than human, and have fair-sized ears set wide apart. There's perhaps no better example than the elephant. Of course, elephant ears are notable for a variety of reasons. For one thing, they can move their ears back and forth, which helps cool them down. They contain a network of blood vessels, which help to regulate the elephant's temperature, circulating blood through its ears. Elephants can hear things at 20 frequencies lower on the hearing range than we can, in the range known as infrasound. That low rumbling sound you sometimes hear elephants make, that's the thin edge of the wedge. Other elephants can pick up on such rumblings, and others we cannot detect as far as 6 kilometers away. These long-distance conversations are useful in letting male elephants know when females are around and if they're in heat. Mating season and this rumble in the jungle is no joke for elephants. It's only for a few days out of every 2 to 4 years that females are ready to mate. And that's when they send out this mating call. It's the call that no bull elephant wants to miss. As well as those gigantic flapping ears, elephants can detect sounds through their trunks and their feet. Both come with receptors that pick up on those low-frequency vibrations in the infrasound spectrum. When you see an elephant with their trunk on the ground and their feet carefully positioned, it means they're having a good old listen. They could be tuning into the subsonic rumblings made by other elephants, or listening out for thunderstorms and the approach of rain. In the dry season on the African plain, this is a huge advantage, as they can move towards the rain and towards water, which is vital for survival. The large ears of bat-eared foxes and elephants give them their ability to amplify sound. But there's one rather singular animal who uses another part of its body to amplify sound. Because it's important to hear what's going on, communicating your message can be a matter of life and death. To make our case in point, we travel to the world's third largest island, one whose very name has become a synonym for the wild side of nature, Borneo, home of the Proboscis monkey. This primate, found exclusively in the wilds of Borneo, has many unusual characteristics. One of the largest and most distinctive of all primates, they have partially webbed feet and make fine swimmers. And it's the male of the species who develops the largest nose. But its protruding nose is also an aid in spreading the alarm when danger is near. When feeling threatened, the male proboscis monkey's nose swells up, and this swelling means his nose acts as a sound chamber. The monkey's call of anguish or alarm echoes off those chamber walls. Its cries travel further, hopefully reaching females and warning them of impending danger. Most often crocodiles or clouded leopards, or sometimes, sad to say, humans. The proboscis monkey is on the endangered species list. From a nose that works as an amplifier to an up-close examination of creatures in the insect world, whose sense of hearing originates in some odd places. Cicadas and grasshoppers carry their ears on their abdomens. While crickets and katydids hear through holes in their hind legs. Their reason for being there? Well, sound detection generally works better when the detectors, the ears, are set far apart. Crickets and katydids certainly need their sensitive auditory system. As most of us know from experience, the leaf-like insect has a proclivity for making a lot of noise, especially on warm summer nights. It's critical for survival to discriminate between the sounds of a receptive mate singing right back and the sound of a bat whose calls may be in the same frequency. Striking a bum note in this case could be a matter of life and death. Especially when you consider the animal which crickets and cicadas have most reason to fear, the bat, and its super sense of echolocation. Bats, of the kind the cricket and cicada need to listen out for, rely on echolocation, which in simple terms is like seeing through sound. It's an interesting fact that bat species use echolocation all the time. Bats are generally nocturnal and catch their prey while in mid-flight. Echolocation enables them to decode thousands of sound signals, These sound signals bounce back from a tree's leaves, branches, and trunk to build a sound picture of their surroundings. Echolocation helps bats to find their preferred food types, insects such as crickets and cicadas. But the really neat thing about echolocation is that it also enables bats not just to hear a sound, but to really make a noise. Bats generate ultrasound waves through their larynx and emit sounds through their open mouth or nose. Fascinating and recent research has shown that quite conclusively, bat males sing in ultrasound to attract females. What the research seems to prove is that female bats are more attracted to those male bats whose mating calls are more elaborate. Even stranger and more revealing is the fact that both male and female bats sing in secret, at a frequency perhaps few, if any, creatures in their environment can hear. It's almost as Bram Stoker put in Dracula, "The children of the night, what sweet music they make." The forest at night. Aside from the sound of a bird tweeting, wind blowing, or the crackling of twigs, seems to us a pretty quiet place. But with the right kind of ears, it is a cacophony of sounds. Somewhere in the midst of that primeval dark, an owl flies, almost noiselessly, through the night air. Silent but violent, the barn owl as depicted here is reckoned by some as the most widespread bird species on Earth. Sharp eyesight and the fact that they fly almost silently through the air have a lot to do with their prolific success as predators. But maybe the real stealth weapon in the owl's arsenal is their super sense of subsonic hearing. You won't hear an owl coming unless they issue their signature call, but they will most certainly hear you. Owl ears are also asymmetrical, which is to say the left ear is not level with the right. As with all smart evolutionary design, there's a good reason for this. Asymmetrical ears give them the direction of sound, the difference in time it takes for a sound to reach the right or left ear. Put it this way, owls can hear a rodent moving under several feet of snow from 50 feet away. When you think of it that way, the poor little critters just don't stand a chance. On Animal Super Senses, we see it, hear it, taste it, smell it, and feel it like animals do. The senses are the star of this show, and this episode has been no exception. The sense of hearing has taken us on a memorable journey. But these incredible powers of perception will fight again another day. So join us next time on Animal Super Senses.